at physics paper 2 to paper 2 to May, June 2021. So without much ado, let's begin. First question says, which piece of apparatus is the most suitable for measuring the mass of a pencil sharpener? If you want to measure the mass of pencil sharpener, which piece of apparatus do you use for measuring the mass? A, digital balance. B, measuring cylinder. This is for volume. Newton meter is for force. Ruler is for length. So the answer is A. So the answer is A. The most correct answer is A. So we go to the second question. It says 4 balls with different masses are dropped from the height shown. Air resistance may be ignored. And which ball has the smallest average speed? Okay, smallest speed, speed is kinetic energy. Kinetic energy has something to do with speed, right? So is equals to half mv square. Half mv square. Okay, right? The mass times. So we can calculate the energy. The potential energy equals to kinetic energy. Potential energy is mgh. mgh. So in this question, last time with this question we encountered this type of question, but we did it in another way. But this one, calculate the energy. Potential energy will be equals to kinetic energy. So we bring the energy, you calculate the speed, you make speed the subject, and you'll be able to tell which one has the smallest speed. So the potential energy for this one, mass is 4. 4 times 10, that's 40 times 140. So the potential energy for this one, for A, is 40. The potential energy for B, 3 times 10, 30. 30 times 2, 60. Potential energy for this one is 60. Potential energy for this one is 2 times 10, that's 20, times the height is 3. 2 times 10, 20 times 3, 60. Potential energy for this one is 60. Now the potential energy for this one, which will be equal to the kinetic energy. Potential energy for this one is 1 times 10. 10 is the gravity, okay, G. 1 times 10 times height. Height is 4. 1 times 10 is 10 times 4, 40. So the potential energy for this one is 40, which are equal to kinetic energy. So you make the speed the subject. Potential energy equal to the kinetic energy at equilibrium. Potential energy equal to kinetic energy. So you bring the value here, 40 for this first one. So you substitute it to this formula. You say 40 is equal to, because potential energy equal to the kinetic energy, 40 equal to half of the mass. Half of mass is what for this one? 4. So half of 4 is 2. So I can simply just say 2. Half of 4, that's 2. 2 times v square. So you divide both sides by 2, you get 20. If you divide both sides by 2, you get 20. 20 equals to v square, and you find the square root of 20. Okay, you get the speed for A. You find the square root of 20, you get the speed of A. So square root of 20 is 4 point something. So your v here will be 4 point something. The speed here will be 4 point something. Okay, you do same for 4 point something, maybe 4.6 or 4 point whatever. Okay, let's assume 4.6. You do same here. The energy is 60. 60 equals to half of the mass. What's the mass? Mass is 3. That's 1.5. 1.5 times v squared. So 60 divided by 1.5. What do you get? 60 divided by 1.5. What do you get? And then you find the square root of that. Obviously, it's bigger than 4.6. Obviously bigger than 4.6. Right? Obviously bigger than that. So the speed here will be bigger. Same you do here. The mass is 2. Half of 2 is 1. 1 times v square equals to 60 equals to 1 times v square, which is v square. So square root of 60, you get the number. 60 divided by 1.5. So this, find the square root of 60 here. So this one, 60 divided by 1.5, we say 40 equals to v squared. So find the square root of 40. If we find the square root of 40, we find this one, the speed of this one. If you find the square root of 40, we get the speed. So V here for B will be 6.3. 6.32. So that's the speed of B. Now what's the speed of C? You find the square root of 60. What's the square root of 60? We find the square root of 60. V will be equal to what? V will be equal to the square root of 60. Okay? Then for this one, we bring the energy. We say this energy equal to half mv squared. You know, half of the mass. The mass is 1. So half of mass times v squared. Half of 1 times v squared. That's 0.5. Right? Okay, the speed of this one is 7.7. The speed of this one is 7.7. Speed of this one is 7.7 meter per second. Okay? Now the speed of this one will be, you cross multiply this one this way because you cannot, it's going to be 0.5, which eventually, so this will be 80 equals to v squared. What's the square root of 80? 80. What's the square root of 80? The square root of 80 will be 8.9. So v equals to 8.9. V equals to 8.9. So the question says, we've got the speed of this one, the speed of this, the speed of this. And what's the square root of 20? What's the square root? Let's get the actual value for this one. I know it's 4 point something. Square root of 20. We get 4.47, which is 4.5. So approximately 4.5. So the question say, which ball has the lowest average speed? So obviously is this one, because the speed of this one is 4.5. The speed of B is 6.3, speed of this is 7.7, the speed of this is 8.9. So the answer is A. The answer is A. Is that okay? Is that okay? I think this is a better method than the method we looked into this one previously. Okay, now let's take a look at question number 3. Question number 3, it says, a ball is thrown vertically upward through the air. A resistance acts on the ball, which graph shows how its speed varies with time. A ball is thrown vertically upward. So we throw the ball upward through the air. A resistance will act on the ball. Okay, a resistance will act on the ball. Which graph shows how its speed varies with time? Okay, if you throw the ball vertically upward, this one does not show there is effect of air resistance. So A is wrong. B, if you throw it vertically upward, it's working against that. B is close, but B is not correct. It's close. B is close. A ball is thrown vertically upward. When it gets up, the ball will travel like this, actually. The ball will travel like this. It will travel like this. If you throw a ball vertically upward. And then, when it gets up, it will start coming like the projector one, like the one we had for when someone jumped out of aeroplane, when we had terminal velocity. So when it gets to the up, because air resistance is acting on it, the weight and air resistance, it will reach a point where it will reach equilibrium state. So I think the best answer is D. The best answer for this speed time graph for throwing a ball vertically upward is a D. Okay, now we go to question number 4. What's the best description? It says, question number 4 says, what is the best description of the meaning of mass of an object? Is the quantity of matter in an object, right? The space occupied, this is for volume. The force that gravity exerts on an object, that's weight. The resistance of an object to changes in motion. We are defining what? Mass. The closeness of packing of molecule in an object. The closeness of packing of molecule in an object. The resistance of the object to changes in motion. See the resistance? Mass. You say, what is the best description of the meaning of mass? Mass is the quantity of matter in an object. Okay? So let's see which one is closer. This is wrong. It's not volume. Anything, say the space occupied is volume. The force is, this is weight. The closeness of packing it doesn't have to do with closeness of packing. This one is like you're talking about solid, as if you're defining the matter as solid. The resistance of object to changes in motion. Could be. Okay, this could be. Okay. Okay, so let's move on to the next question. Let's move on to the next question. Okay, question number 5. Question number 5. We say a measuring cylinder contains 40 centimeter cube of water. A measuring cylinder contains 40 centimeter cube. So the water in this measuring cylinder is 40 centimeter cube. But we've exerted something in it, right? So the volume has increased to a certain number. The volume has increased to a certain number. A stone of mass 94. So mass of stone is 94. Okay, let's take note of that. Is lowered into the water and so that it's fully submerged as shown. So that it's fully submerged as shown. What's the density of the stone? To get the density of the stone, density is mass over volume. To get the density, we already know the mass, right? Mass over volume. We must get the volume of the stone. We must get the volume of the stone. The 40 is not the volume of the stone. The 40 is the volume of water in the measuring cylinder. Now we have to read out what's this value. Here is 70, here is 75, here is 76. Looks like 76 if we're not mistaken, right? They zoomed it up. This is 76, right? So the 76 is the volume of water and stone together. So V, stone and water. Stone plus water is 76. So to find the real volume of stone, we have to find the difference, right? We have to find the difference. So volume of stone, volume stone only, will be equal to 76 minus 40. 76 minus the volume of water. 76 minus 40, we get 36, right? So we get 36. When we do that, we will now use this 36 as the volume of the stone to calculate the density. V stone equals to 36 centimeter cube. So since the mass is given in gram, we can leave the volume in centimeter cube. We can leave the volume. So we substitute these values. 94 divided by 36. 94 divided by 36, and we see what we get. 94 divided by 36, we see what we get. We get 2.6. We get 2.6 gram per centimeter cube. 2.6 gram per centimeter cube. So we go and look for our answer. 2.6 is D. Okay, you can see 2.6 is a D. Now we go to question 6. Question 6 says the essential load graph for a spring is shown. Now the stretched length of the spring is 70 centimeter. The stretched one is 70 centimeter. When an object is suspended from the spring, the length is 90.2. So let's find the extension. Okay, extension is the new length minus the original length. The new length minus the original length. So 90.2 minus 17, we get 2.2, right? We get 2.2 if you find the difference. So this extension is 2.2. So our extension is 2.2. Now let's see what the question wants from us. Let's see what this question wants from us. Okay? So extension is 2.2. The plot of the graph is extension against the load. Now you say when an object is suspended from the spring, the length of the spring is 90.2 centimeter. Now what is the weight of the object? So to get the weight, look for 2.2 on the extension side, trace it to the graph and trace it down. Okay, this is 2.1, 2.2. I think this point, right? This is 2.2. So we go to trace the 2.2 to the graph, to the line graph, where it touches the graph. This point touches at this point. So we trace it down. We trace it down, right? We trace it down and we will get. So the weight is 3 Newton. The weight is 3 Newton. So we just go and we circle our answer. The weight is 3 Newton. Now we go to the next question. We go to the next question, question number 7. Now we say a satellite orbits the Earth in an anti-clockwise direction at a constant speed. Yes, always. Anti-clockwise means it's going this way. It's going in opposite direction of the clock. It's going like this. It's rotating the Earth like this. The satellite is rotating like this in the anti-clockwise manner. When the satellite is in position shown, in which direction does the resultant force act upon it? If the satellite is in position shown, in which direction will the resultant force act upon the satellite? A, this way? No, because the satellite is moving like this. So the vertical force, okay, the resultant force will be in the direction this way. That the resultant force will be in this direction. Okay, the resultant force acting on the satellite will be in this direction of D, this way. The resultant force will be in this direction. Is that okay? So D is the closest, so we choose D. Now we go to question number 8, so that we can do as fast as we can. It says a tennis ball has a mass of 57. So mass is 57. The tennis player hits the tennis ball with a tennis racket, and the tennis has a velocity of 25 meters per second. So we know that, if they're asking for momentum is mass times velocity. So this one is not in the standard unit. We can change it to standard unit by dividing with 1000. Since this one is in standard unit, meter per second. So this one we can change. But let's read the question first. The velocity of the tennis ball when it leaves the player's racket is 15. This is when it leaves in the opposite direction. Okay, let's say the tennis ball is going this way with a speed of 25 meters per second. Okay, the speed when the ball hits the tennis racket, let's say this is the racket. Tennis racket. And then when the ball hits here, it starts to go in the opposite direction with a speed of 15 meters per second. Start going in the opposite direction with a speed of 15 meters per second. Okay, so originally it's 25 meters per second before the ball hits the racket. Okay, the opposite direction 15 meters. We know the mass also, so we should keep all these things in mind. Now the average force exerted by the tennis racket on the ball is 35. The force is 35. Okay, the force is 35. You know this formula which says F equals to the Newton's second law of motion, mv minus u over t might be useful. Let's see what the question wants from us, because they're giving us for how long. You see, they're asking for time. How long is the tennis ball in contact with the tennis racket? For how long? For how long is the tennis ball in contact with the tennis racket? So like we said, this formula is what we're going to use. So you make t the subject. We make t the subject. So you say ft, which is impulse. Ft, if you cross multiply, ft, which is impulse, equals to change of momentum. If you cross multiply, we're still using the same formula. If you cross multiply, this is over 1. If you cross multiply, it will become F times T equal to M into V minus U. Okay? This is change of momentum. Change of momentum equal to MV minus MU. Okay? Equal to impulse. Okay? So we want to make time the subject, because they say for how long. So we say this is equal to M V minus U over F. Okay, so this is what we use now. We substitute the value here. But remember, it's in opposite direction. Minus will become plus. Minus will become plus. Right? Let's see. Minus will become plus. Let's see what we have. So T will be equal to our mass, which is our mass. I think we should change to divide by 1000. If you divide this by 1000, you get 0.057, right? If you divide by 1000, to put in kilogram into the final will be let's say we have Z 15, 25 minus 50, 15, okay, 15 minus 25. Let's see first. I'll see whether this way is the right way. We see. The first is 35 Newton. So 15 plus 25, you get 40. So you say 0.057 times 40 divided by 35. Divide by 35. Divide by 35. So this gives us 0.065. This gives us 0.065, which is correct. This gives us 0.065 seconds. Okay, the big question is, why do we say minus minus? So our answer is C. Why do we say? Because they are going in opposite direction. This is the final speed. You know it was coming, this is the original speed 25. And then the second speed is 15. So since they are going in opposite direction, there is one minus here. Original minus in the formula. And then the second minus is because they are going in opposite direction. Like we put a small minus here. So minus minus become plus. That's how I got 40. 50 plus 25, I got 40. 40 multiplied by the mass divided by 35, you get this one. So the time, how long it took, or it was in contact with the racket, the ball was in contact with the racket, 0.065 seconds. Okay, now let's move to the next question. Let's move to the next question quickly. So this question is about 4 methods used to produce electrical energy. 4 methods that is used to produce electrical energy. Now, which method has a correct description? Which method has a correct description? Method, energy source is renewable, emit carbon dioxide. Now, hydroelectric power station, the one we built down in the water and use the force of the moving water to turn the blades of turbine. It's called hydroelectric power. And the energy source, is it renewable? Yes, it's a renewable source. Does it emit carbon dioxide? No, it does not emit carbon dioxide. A looks correct, but we have to check other options. A looks correct. Coal fire, is it renewable? No, coal is not renewable, it's a fossil fuel. It's not renewable. And does it emit carbon dioxide? Yes. So this one is wrong because it emits carbon dioxide. Wind turbine, is it renewable? Yes, it's renewable. But here it's saying no. Does it emit carbon? It does not emit carbon. So this one is wrong because it's giving wrong description. Nuclear power station, is it renewable? No. Is it renewable? No. Uranium can finish, right? And is it emit carbon? Yes. So this one is wrong. So the correct answer is A. Correct answer is A. So we move on to question number 10. Move on to question number 10. Question 10 says a stone is released from rest from a high building on earth. The air resistance is negligible. What is the velocity when it hits the? When it's 45, what's the velocity when it has 45 meters? A stone is released from rest from a high building on earth. Air resistance is negligible. What's the velocity when it has 45 meters? Okay, so we have, at equilibrium, potential energy is equal to kinetic energy at equilibrium. Potential energy is equal to, always remember, sometimes when you need to solve equations regarding energies, remember this. So what's the potential energy? You write mgh. Say mgh is the formula for potential energy. You write the formula for kinetic energy, half mv squared. You write the formula for kinetic energy, half mv squared. Remember, if you look at the question, they did not give us the mass. If you look at the question, they did give us the mass of the stone that has been released from the earth building. Okay, so the mass here, we cancel the mass here. The mass here, we cancel the mass here. Gravity is a fixed number. The height has been given to us, h, so we can find. So gravity is 10. You say 10 times, what is the height they gave you? They say the height of the stone is 5. So you say times 5, which is 50. So 5 times 10 is equals to half v square. Equals to half v square. So this half, you cross multiply. This times this is 50. 50 times 2, I get 100. So I have 100 on the left is equals to v square. Okay, how do I get 100? 50 times 10 is already 50. 5 times 10 is 50. Then if you cross multiply with these two, you get 100. So equal to v square. So we find the square root of 100. Square root of 100 is 10. So if you find the square root of 100, you have 10. So our v is equals to 10 meters per second. Our v, the speed of the stone, is equals to 10 meters per second. So if that is true, our answer will be B. Okay? So our answer will be B. So we'll move on to the next question. Question number 11. Question number 11, we say the power input to an electric motor is 400. You know, input power over output power equals to efficiency. The efficiency of the motor is 85%. How much power was wasted? Okay, let's see the output. Then we'll now find what was wasted. So we say efficiency is equals to output power. So I'll just say P out. PO means P out over P in, input power, P in, P out times P in, multiply by 100, okay? Multiply by 100. But this is already given in the percentage, 80%. Okay, so we put our 85 here because they say the efficiency is 85%. So we put our 85%, our input power, P in is 400 watts. So we substitute and we find the output first. So output, if you cross multiply, you see that output is equal to efficiency times power input. So I'll say P out, my P out is equal to my P in times efficiency. My P in times efficiency. Multiply by efficiency. So my P is 400. My P is 400. Efficiency is 85. But we'll see whether we need to convert this one to decimal. 85% means 85 over 100, right? So, which is, I think we should convert this one. Yeah, you have to convert this one to, which is 0.0, because 85% means 85 over 100. So if you change to decimal, you get 0.85. So 0.85 times 100 times 400. 0.85 times 100. 0.85 times 400. We get 340. So here you get 340 watts. This is the power output power. So what is wasted? They're asking us what is wasted. Imagine you put 400 in, and you got the output to be what? 340. So you subtract to know what it has been wasted. You say minus 340. 400 is the input. The output you got was 340. What do you get? 60. So 60 watts of energy power has been wasted. 60 watts of power has been wasted. So the answer is A. The answer is A. 60 watts of power has been wasted. 60 watts of power has been wasted because your input, the power you put in, is bigger than the power we got as the output. So some has definitely been wasted. Now let's go to question 12. Question 12 says a book has a mass of 400 grams. Okay, I think we all convert to kilogram, this mass. So 400 divided by 1000, you get 0.4. This will give us 0.4 kilogram. This will give us 0.4 kilogram. Okay, just to be on the safe side. Now we say the surface of the book in contact with the table has a dimension of this. So we can find the area since it has a dimension. So 0.1 times 0.2. Let's know what the area will be. Let's multiply the area out. 0.1 times 0.2, we get 0.02. We get 0.02. Okay, meters square. Now, it said the gravitational field strength G is 10. So we know G is 10. What's the pressure exerted on the table? To get the pressure, you must get the weight. Since you know the mass, you have to get the weight. So weight is mass times gravity. So you get your weight to be 0.4 times 10. You get that would be 4. 0.4, which is the mass, multiplied by 10 in order to get weight. That will give you 4. So 4, to get pressure now, if you want to get pressure is force or weight over area. Weight or force over area. So we say 4 divided by this 4 that we got for the weight, divided by the area we calculated before. Remember 0.02. 4 divided by 0.02. 4 divided by 0.02, we get the pressure. So what's our pressure? We get 200. Pressure equals to 200 Newton per meter square. Newton per meter square. 400 Newton per meter square. So our answer is D. 200 Newton per meter square. Not 400, 200. Okay? Now let's go to question 30. Question 30, it says a horizontal metal plate of area. So it's giving us the area of a metal plate. Okay, area 0.5 meters square lies at the bottom of a lake at a depth of 400. This is H. We have area, we have height. Now the density of water is this. We have density. And the gravitational field, we have G. What is the downward force acting on the plate due to the water? What's the downward force? Okay, you remember that pressure equals to force over area. Force over area. Okay, but we have to calculate the pressure first because they did give us the pressure. And pressure equals to rho GH. Pressure equals to density. Rho means density when I say rho, okay? Density times gravity times height. Density times gravity times height. So let's calculate the pressure. Before we can calculate the downward force, we must get, we are going to calculate force from this pressure formula. Pressure in solids. You know this formula for pressure in solids. This formula for pressure in liquid and gas. This formula for pressure in liquid and gas. So let's calculate the pressure of the water first. The density of the water is 1000 multiplied by 10, which is the gravity, then multiplied by height. They gave us a height, 40, so multiply by 40. What's the pressure? Is it 400,000? Yes. This will give you 400,000. 400 delta. So we get the pressure to be 400,000. This is not what they want us to find, but you need to find the pressure first before you can find the force. You get 400,000 for the pressure of the solid. Now to find, you bring the formula, you bring it here and make force the subject. Make the force the subject. You cross multiply F equals to P times A. So here you simply come here, you say F, the force, is equal to the pressure multiplied by the area. Pressure multiplied by the area. So pressure multiplied by area. So if you do that, that will give you, this will be equal to, the pressure is 400,000 times the area. 400,000 multiplied by area, we get what? Multiplied by area. What was our area? Area was 0.5. Okay, times 0.5. 0.50 is same as 0.5, okay? 0.50. This will give you is it 800 or 200? 200, okay. Question number what? 13. Okay, so it's 200 because 0.5 means half of 400, which gives you 200. 200. The kilonewton means, it means 1,000. This one has replaced the kilo. Okay, so it's this one, C. We go to question 14. Let's go to question 14. Which row describes the force between, question 14, which row describes the forces between the molecules and motions of molecules in a gas? Okay, for gas, the forces between the molecules is a weak one. It's not a strong one. So, and then the molecules, they move, the motion of molecules is that they move freely, they don't vibrate. So the answer is between C and D, and the answer is C. The answer is C. They move freely, they don't. Vibration is for solid. Okay, so question 14 is C. Let's go to question 15. Question 15 has something to do with the Brownian motion. Has something to do with what? Brownian motion. Very small polygrains are suspended in water. A bright light shines from the side. When looked at through a microscope, small specks of light are seen to be moving in a random jerky manner. Small specks of light are seen to be moving in a random jerky manner. This is the eye looking through the microscope to look at polygrains in water. Okay, and you shine light to it and see what you see, how the polygrains are moving. Now, what is the moving speck of light? Of course, it's the polygrains, right? The polygrains being hit by other polygrains. No, polygrains are not hit by other polygrains. Polygrains being hit by water molecule. Yes, right? Because there's water here. Is what the reaction is between water and polygrains. So polygrains being hit by water molecule. I think that's the correct answer. To save time, let's move to question 16. Question 16 says a hole is drilled in a metal plate. You drill a hole in a metal plate. Now, what happens to the length of the plate and to the diameter of the hole when the plate is cooled? What happens to the length of the plate and to the diameter of the plate when it's cooled? When it's cooled, the length of the plate, when you drill a hole, the length will decrease. The diameter, when it cools, also the diameter will decrease. So our correct answer is A. Our correct answer is A. Let's go to question 17. Question 17 says, which statement describes a sensitive liquid in glass thermometer? Which statement describes sensitive? Okay, now we have to read through all the options. A thermometer that can be used to measure very high and very low values of temperature. For sensitive, no. No, for sensitive one is a quick one. Okay, now a thermometer that gives the same increase in length of the liquid column for each degree rise of temperature. That may not be absolutely true. A thermometer which is accurate because it has been calibrated. That's not the definition of sensitivity in liquid in glass thermometer. Then we say a thermometer which gives a large increase in length of the liquid column for each degree of temperature rise. Yes, a large increase in length when there is a small increase in degree of temperature. There will be high increase. That means it's very sensitive. For every rise in temperature, you can see a wide range of the length of the thermometer. Okay, question 18. Question 18, it says a block of aluminum has mass of 2 kg. So we have the mass now, 2 kg, and has initial temperature of 20. So we're going to subtract final from initial to get change in temperature. It absorbs 7,300 joules of energy. So this is our energy. Energy has been given. So this question is not going to ask us to calculate energy of temperature. Maybe they ask us to calculate the final temperature. Now the specific heat capacity is this. So our specific heat capacity is this. Now what is the final temperature of the aluminum block? You see they are asking for the final temperature. So you put down your formula. You say energy in thermal energy is equals to mass times specific heat capacity. Mass multiplied by the specific heat capacity times the change in temperature. Final times T2 minus T1. In this case, now because they are asking you for the final, or TF, I can use TF for final instead of T2 minus T initial, which is initial temperature. Okay, so energy has been given 7,300. Is the energy 7,300? Is the energy in joules equal to the mass has been given to be 2. Specific capacity is 913 specific capacity into TF minus T1. TF or T2 minus 20. T1 is 20, right? Minus 20. Okay, you put it like this so that we can find. So you multiply this 2 times this, what we get? 2 times this value, we get 1,800, 8026. We get 8026 here. We get 8026. This 8026 times TF, we get 8026 TF. We get 8026 TF. This 8026 times 20, we get minus times 20. 8026 times 20. 8026 multiplied by 20. We get 36,520. We get 36,520. What we did, what we got here, which is 8020, we use it to multiply what is inside the bracket. So everything goes to 7,300. So what the next step is to move this negative 36,520 to come and this way, it will become addition. So bring it this way, add it fast. 7,300 plus 36,500, we get 40 something thousand. 7,300 plus 36,520, we get 7,300 plus 36,520. We get 43,000. We get 43,820. 23,820, which is equal to 8026 TF. 8026 TF, the final temperature. So we divide both sides by 8026. So TF will be equal to what? TF, final temperature, will be 43,000 divided by 8026. We'll get 23.997, which is approximately 24 degrees. So final temperature is 24 degrees, right? Question number 18. Final temperature is 24 degrees, which is C. Okay? So we move to question 19. Question 19 says, a student set up 4 cans. Each can contains the same mass of water at 90 degrees. The cans are identical except for the outside surface. Which can will cool down the fastest? Cool down the fastest is the dull black surface. The dull black, not shiny black. Dull black is the one that will cool down the fastest. It emits the fastest and it cools down the fastest. So we go to question 20. Question 20 is the thermal energy is transferred by conduction in metal bar. Which statement is not correct? Which one is not correct? Please, they did say which statement is correct. Which statement is not correct? Fast vibrating ions leave the surface. Ions don't leave, electrons that leave. This one is not correct. So it may be the answer, but let's see. Free moving electrons carry thermal energy through the bar. Yes, that's true. Ions vibrate and strike the neighboring ions to make them vibrate. Yes, that's true. Ions vibrate but do not change position. That's true. Ions don't change position. Ions vibrate and cause the fast moving electron to move. So the answer is A, because it's the one that is not correct. Now we go to question 21. 21 is what? Is a water wave passes into a region where the wave travels more slowly. It passes into a region where the wave passes more slowly. Now, as it passes into the region, what happens to the frequency and what happens to the wavelength of the wave? So, if you move into a region where you are more slowly, the frequency will remain same, but the wavelength will decrease when you go to a more slowly place. So, our answer will be C, probably, right? Our answer will be C. Okay. Right? Now, let's go to the next question. Question number 22. Let's go to the next question, question number 22. It says light travel at a speed of 8 times 10. This is the speed of light. Okay? Strikes the surface of a glass and undergoes refraction as it enters the block. So the diagram shows a ray of light before and after it enters the block. First of all, refractive index is equals to the speed in air over speed in glass, right? It enters a glass, right, over speed in glass. This is refractive index. Also, there is also a connectivity between refractive index. Refractive index is sine I. If it's coming from a less dense one, sine I over sine arrow. Arrow is the angle of refraction. While I is the angle of incidence. Okay? So the diagram shows a ray of this light before and after it enters the glass. Now you can see this is angle I, the incident angle, and this angle R, the refracted angle. Now, what is the speed of light in the glass? What's the speed of light in the glass? So the first thing we're going to do is to find the refractive index, and then we'll bring it here to calculate the speed of light in the glass. We're going to use this one first, We're going to use this one first to calculate. So we say sine I, which is sine 55, okay, over sine 33, So we get refractive index. What do we get? Sine 55 divided by sine 33. What do we get as the refractive index? It's going to be 1 point something. We're going to get 1.5. Okay, so we get our refractive index to be 1.50, which is 1.5. So once you get the refractive index, you come to the second form, this formula, to find the speed in glass. We know the speed in air, which is 3 times 10 to the power of 8. So you say 1.5 is equals to our 3 times 10 to the power of 8 over V glass times 10 to the power of 8 over V glass. So you make the V glass the subject. The V means speed, okay? Speed in a glass. So if you make it the subject, V glass, if you cross multiply, V glass will be this one divided by this one. So this will be 3 times 10 to the power of 8 over 1.5. You get 2. You get 2 times 10 to the power of 8. Okay, so because 3 divided by 1.5, you get 2. So you get 2 times 10 to the power of 8. So that would be the speed of the material in glass, yes. 3 times 10 to the power of 8. So that would be our speed, the speed in a glass. That would be the speed in a glass, which is B. Right? Question 22, B. Which is B. Okay, we go to question 23. Question 23 says that in which statement about the image of an object formed in a plane mirror is correct? The image of an object formed in a plane mirror is correct. It's smaller than the object. Which statement about the image of an object formed in a plane mirror is correct? It's not smaller than the object. They are same size. So it's wrong. B, it is the same size as the object. That's yes. C is larger than the object. No. It's inverted. No. It's only laterally inverted, but it's has same size. Okay. Right? Am I right? Question 23. Yeah. So 24. Now let's go to question 24. An object is placed in front of a thin converging lens. Now the diagram shows the path of the two rays from the top of the object. An object is placed in the front of a thin converging lens. The diagram shows the path of the two rays from the top of the object. Okay, so you go to extend this ray. Okay, in your case, use a ruler to extend this. Okay, use a ruler so that you have absolute straight line. And then you extend this one also. Where they meet, that's where the image will be formed. Where they meet, that's where the image will be formed. You must use absolute what? Absolute ruler. You must use ruler to get absolute. Okay, now the image, see, you show your arrow. This may not be absolute because we are not using ruler, we're just sketching. Now an image of the object is formed on the screen to the right of the lens. How does the image compare to the object? Obviously, if you extend this principle as this, you can have your image here. This is your image. You can see that where they meet is where your image is. You can see the image is larger than the object, right? It is larger and inverted. That's correct, right? It is larger and inverted. That's the answer. It is larger and inverted. It's not larger and same way up. It's not same way up. It's inverted. This one is up. This one, the image is down. Okay, this image and this object. This object. Okay, we move to the next question. Question 25. Here are three statements about the speed of electromagnetic wave. The speed of electromagnetic wave in a vacuum. The speed of electromagnetic wave in a vacuum is this. No, that's wrong. This is the speed in solid. Right? This is a solid. Speed of sound. This is the speed of sound in solid. Okay, this is wrong. The speed of electromagnetic wave in a vacuum is that. Yes, this is correct. And the speed of electromagnetic wave in vacuum is approximately the same as in air. That's correct. So these are the 2.2 and 3. So the answer will be C, 2 and 3. Right? Is that right? So 25. Okay. 26. Let's take a look at question 26. The sound from a loudspeaker must pass through two materials to reach a microphone. The sound from a loudspeaker must pass through material to reach a microphone. Now, which combination of materials give the shortest time for the sound to reach the microphone? The shortest time for the sound to reach microphone. I think the sound travels fastest in solid. Because in solid, the molecules are very close together. So the particle, by vibration, if you pass the sound by vibration from one molecule or particle to another. So if you make material 1 and 2 solid, then the sound will travel faster. Air is a gas. So A is wrong. Air is a gas, B is wrong. The answer is between, this is liquid. It's not solid. So the answer is C. Okay? Sound travel fastest in solid. Then fastest solid, faster liquid, fast gas. So it's from solid to gas in order. Which statement, question 27, is which method does not demagnetize a bar magnet? Okay, which method does not? Heat the bar magnet and place it in east-west direction to cool. Think this way, demagnetize it. We're looking for what will not demagnetize it. Place the bar magnet in east-west direction and hammer it. It will demagnetize it. Place the bar magnet in a coil connected to AC supply. AC supply will demagnetize it. Only a DC supply will not demagnetize it. AC supply is to magnetize it. When you are doing magnetism, that's when you use AC supply. If you put AC supply, it will not demagnetize. Okay. Place a bar magnet coil connected to a DC. Yes. D. 27D. This one will demagnetize. Will not demagnetize. Okay, now let's move to question 28. Question 28 is 3 piles of small nails PQR are placed on a bench below 3 electromagnets. Nails are placed between 3 electromagnets. One set of nails is made of copper, one of soft iron, and one of steel. So copper, soft iron, and steel. Now diagram 1 shows the situation when the electromagnets are switched on. Diagram 1 shows when the electromagnets are switched on. Diagram 2 shows the situation when the electromagnets are switched off. So this is diagram 1 for the different materials. Okay, small nails. Diagram 2 is when it's switched off. So even when it's switched off, this one didn't fall off, this one fall off, and this one. So they want us to identify them. The one that didn't fall off is obviously steel. So the answer is anyone that has arrow in the end, steel. The one that didn't fall off is the steel. So even when you switched off. So our answer is between A and C. Our answer is between A and C for question 28. Now let's see Q. What is Q? Q fell off. When it switched off, this also fell off. Okay. Let's look at when it's on. Okay, when it's on. When it's on, it's not means P is not a magnetic material. Because when it's on, P was not magnetized. So P is not a magnetic material, but Q is a magnetic material. So we go to the option between A and C. Copper is not a magnetic material. This one, Q, is a magnetic material. So the answer is A. The answer is A, right? We go to question 29. Question 29. A magnet is suspended by a cutting thread. A magnet is suspended by a cutting thread. Now the magnet is displaced, then allowed to swing freely until it comes to rest. Allowed to swing freely until it comes to rest. Why does the magnet always come to rest, pointing in the same direction? A, because of the interaction between the electric field of the magnet and the electric field of the earth. No. That's why it always comes to a stop in the same direction, pointing in the same direction. No. Because of the interaction between electric field of the magnet and magnetic field of the earth. No. Because of the interaction between magnetic field of the magnet and gravitational field of the earth. No. Because of the interaction between magnetic field of the magnet and magnetic field of the earth. Yes. Interaction between magnetic field 29. Interaction between the magnetic field of the magnet and the magnetic field of the earth. It's not because of electric and magnetic field mixed together. It's because of magnetic field of the magnet interact with the magnetic field of the earth. Okay? Okay. Now question 30. What do we have for question 30? A student rubs a plastic rod. A student rubs a plastic rod with a cloth. Now the rod becomes positively charged. The rod is now positively charged, right? Meaning the cloth is negative. Okay, they rub this one with this, the rod becomes positively charged. What has happened to the rod? It has gained. If you are positively charged, what happens to you? You've lost electron, right? You've lost electron. If you become, you remember metals. When metals lose electron, they become positively charged. So that idea from chemistry should help you answer this question. It means you have lost electron, right? Question 31. An isolated metal sphere is positively charged. This one is positively charged. It's then brought near to another isolated metal sphere that is neutral. If it's neutral, means it's just mixed up with positive and negative. What happens to the charges at the neutral sphere as the positively charged sphere is brought close to it? You bring a positively charged, the negative charge will be this way, while the positive will remain fixed. All the negative charge will align this way, right? All the negatively charged this way, align this way, while the positive will be fixed. Positive will not move. Okay? Now, so some positive charges move to the left and some negative charge move to the no, right? So positive charge move to the right and some negative charge move to the no. Some positive charges move to the right, but the negative charge do not move. Some positive charges do not move, but some negative charges move to the left. Yeah, the answer is between C and D, right? And it's D, right? The answer is the D, right? Because the positive charge do not move, but most of the negative charge will move to the left. This way is considered the left because it's shown here. So our answer is D. We move to the next question. Question number: which circuit has a zero radian diameter? Zero radian diameter. Which circuit has a zero radian diameter? Let's see. Current flows from positive like this. This one will not have a zero radian because the diode is fixed properly. The diode is fixed properly. Now let's see this one. This one will not have a zero radian because the diode is also fixed properly. Because diode, if current is coming like this, diode will be in the proper way. Now let's see this one, C. Let's see C. Say current goes like this, diode is fixed, first diode fixed properly, second diode is fixed properly, it's not zero. Let's see this one. Diode is fixed properly, this first diode, but this diode is wrong. So current will be we can no longer go, so it's going to be zero. So our answer is D. Okay, if you have zero in the ammeter reading, is this, because this diode is wrongly fixed. Now let's go to question 33. Now two resistors are connected in series and then in parallel. Two resistors are connected. So what is the combined resistance in each case? In series it will be 10 plus 10, that's 20. Combined resistance will be 20. So the answer is between C and D. So we're going to cancel A and B, because you're going to say R1 plus R2 because they are in series. So which will be 20. Now for parallels, product over sum. That's 10 times 10, 10 times 10, over 10 plus 10, over 10 plus 10. Which is 1 all over 10 plus 1 all over 10. You can do it if you want to do the fraction. Okay, then this one becomes 100 divided by 20. 100 divided by 20. 100 divided by 20 will get 5. We get 5. So the answer will be the one that has 5. Yes, which is this one, C. So our answer to this question is C. Our answer to question 33 is C. Now let's go to question 34. Question 34. The diagram shows a combination of 4 logic gates that produce an output signal at R that depends on the states of the inputs P and Q. Depends on the states of the input P and Q. Okay? This is a NOT gate. NOT gate. Meaning, NOT gate means if 0 go here, you get 1 here. So if I put 0 here, I'll get 1 here. If I put 0 here, I'll get 1 here. If 1 and 1 go into AND gate, you get 1 here. If 1 go into NOT gate, you get 0 eventually here. Okay? Which single logic gate produces the same effect as the combination? Okay, let's try 0 and 1. If I put 1 here, 0 go here, I get 1 here. 1 go here, I get 0 here. 1 and 0 go to AND gate, you get 0. 0 go to this NOT gate, you get 0 go to NOT gate, you get 1. So the next one we try 1 and 0. We also get 0 1 go here, we get 0 0 go here, we get 1. Then let's try 1 and 1. 1 and 1 go here, we get 0 0. We get 0 0 0 0 go to AND gate, you get 0 0 go to NOT gate, you get 1. So it's from bottom up, it's from bottom up. So this is an OR gate. This will give rise to an OR gate. So our answer will be an OR gate, because when you do 0 0, you get 1. When you do 0 1, you get 1. When you do 1 1 0, you get 1. When you do 1 1, you get 1. So this is an OR gate. Okay. Now let's go to question 36. Okay. 35. Let's go to 35. A solenoid is connected to a very sensitive ammeter. A rod is inserted into one of the ends of the solenoid. Now the ammeter shows that there is a small electric current in the solenoid while the rod is moving. So while the rod is moving, there's a small current. Now which rod is being inserted? A heated copper rod? No. Copper is not a magnetic material. A magnetized steel rod? Yes, steel, right? A magnetized steel rod. An uncharged liner? No. Rod? No. A radioactive? No. Okay, these are not magnetic material. The only magnetic material that can generate current when it enters into a solenoid is a steel rod. Now we go to question 36. Question 36 says that this is a transformer. The diagram shows a transformer. Number of turns in primary, and voltage in primary, turns in secondary, and probably they want us to find the voltage in secondary. So voltage voltage in secondary over number of turns in secondary is equal to, it doesn't matter which one you write first, equals to voltage in primary over number of turns in primary over number of turns in primary. So we make Vs the subject. They want the voltage in the secondary, the output voltage here. They want the output voltage here. So we can make it the subject. So Vs is equal to this times this. We multiply this and this, cross multiply them, divide by this one, cross multiply. So Ns multiplied by Vp, multiplied by Vp over Np. Okay, over Np. So we put the value here and see what we get. So our Ns, that's the number of turns in secondary, is 115. So I write my 115 times the voltage in primary. What's my voltage in primary? 22,000 times 22,000. That's my voltage in primary. Over, what's my NP? Number of turns in primary, 550. Over 550. So you key this one into your calculator, what do you get? You get 4,600 volts. You get 4,600. Question 36, right? 4,600 volts. So our Vs is equals to 4,600. Okay, so this is how to calculate use the transformer equation to carry out any calculation. So our answer is C. We move to question 37. Question 37 says, which role correctly states how nuclei behave during nuclear fission and during nuclear fusion. Remember, fusion is joining, fission is splitting. Okay, this one is split, and this one is nuclear fission is split, while fusion is join. To join two atoms together, join. Okay. Question 37 says A says nuclei join together. No, fission is split. It's not joining. Nuclei join together. So anything join A and these two is already out of place. So we choose the answer from here. Nuclei split. So we see which one corresponds. Nuclei join together, nuclei split is C, right? Because here is joining. I already put join here, you can see. Join. So the answer is C. We move to 38. The charge on a proton is E. That E means positive E. What is the charge on an electron? Electron will be minus E. The charge on the electron will be minus E. Proton will be plus E. And neutron will be 0. No charge. Neutron does not have charge. Now, you say, what is the charge on the electron, and what is the charge on neutron? Electron will be minus, so we'll go to the one that has minus, this C and D. Right, when you go to choose from here. Electron is minus. It's not, neutron is not minus, so C is wrong. So C is wrong. D is 0 for neutron. So D is the correct answer. Now we go to 39. Question 39. It says some radioactive nuclei decay to give new nuclei, which are also radioactive. Part of a series of decay is shown. So this one decay to this. You can see loose 4. There's alpha emission here from 238 to 234. So it has emitted an alpha particle, which means you have 4 and 2. That has been emitted even though it's not shown. So this one now decay, you still get 34 and 91. Here to here, you have beta. You have beta decay, which has 0 on top and minus 1 at the bottom. Okay, you say plus this one. Then from here 234 to 230 has lost. Okay, from this to this, another beta decay, plus another beta decay. You have 0 here, you have minus 1 at the bottom. Then from this one to this, it has lost 4 and lost 2. So plus here, you have alpha, 2 and 4. From 230 to 226, and from 90 to 88, it has lost 4 on top, lost 2 on them. So meaning here you also have alpha. So 2 at the bottom, 2 on top. Now, how many decays involve the emission of beta particle? Emission of beta particle, how many decay? 2, right? 1, 2. Beta particle is 2 times, right? Yeah, because see, you have to, if they say how many decays for alpha, you count all the alpha. 1, 2, 3, 4. Alpha is 4 decay. Beta is 2 decay. 1, 2. So the answer is B. The answer is B. Now we go to the last, but not the least. Right? Question number 40. Question number 40 says the graph shows the activity of a radioactive source over a period of time. The activity of a radioactive source over a period of time. What is the half-life of the source? So if you want, this is the highest activity, 120. Half of 120 is 60. So you come here, 60 divided by 2, you get, 120 divided by 2, you get 60. Trace 60 to the graph, trace it down. Trace it down. 2 minutes. The answer is 2 minutes. So you look for 2 minutes in your option. 2 minutes is B. So your answer is B for this question. So with this, we've come to the end of our today's class. Thank you for joining us.